Greetings, students. Welcome to your mathematics content-based session for 2019 ACS Mat11 and DSE Mat11. I'll be your tutor, Mr. Mauritius Imodite. My contact details 081 47 19 337. For your ACSE DSE mathematics examination preparation, the following key points, which do not necessarily make the scope, might be helpful. So this means that you should not neglect the other parts of your course outline, as they have equal chances to appear in the examination. To start off, we have number systems as our first topic. So look at the types of numbers, like natural numbers, prime numbers, the list goes on. Also, we have fractions and percentage. Learn how to do calculations using fractions, and also percentage. Under number system, we also have money and finance, ratio, and estimation. So have a look at them. We have algebra, the next topic, which is containing algebraic representation, indices, and standard form. When it comes to indices, have a look at things like equations expressing numbers given as negative numbers. You can be asked to write them without negative signs. So for example, let me say if you are given 2 to the power of -1, you can be asked to write it as a positive number. I mean as a number that is having positive indices. For example, this would be 1/2. So things like that. And also in equations with indices. For example, let me say let's say you are asked to solve for x. You want to solve for x in the following. So let's say you have 2 to the power of x equals to 8. So what you have to do here is to express 8 as a power of its prime factors. So the next step would be 2 to the power of x equals to 2 to the power of 3. So now the moment the bases are the same, so then it means that the indices are also equal. So the solution for this will be x equal to 3. Alright, so also algebraic manipulation, whereby you can be asked to factorize, or you can be asked to expand. So an example on that, what I just mentioned, can be, let's say you are asked to expand the following. Let's say you have 2x brackets 3 minus x. Now you want to expand that. So what you do, you make this 2x that is outside makes the common fraction. So for you to expand or to remove the brackets, you make sure that you multiply the common factor with everything that is inside the brackets. So you say, okay, I have 2x there multiplied with 3, and also the next step 2x multiplied with negative x. So the next step would be 2x brackets 3 minus, bring the common factor inside, 2x, the negative that is here is already the one that is there, and then the x that is inside the brackets. So just to write it in its simplest form, this would be 2 multiplied by 3, so you have 6x minus 2x multiplied by x, which will be 2 to the power of 2. Because of indices, so we have same basis here, and multiplication, so we add the exponents. Alright. Also we have different types of factorization. You can do grouping. For example, if you wanna look at grouping, you want to group, for example, let me say you have 2x minus 2 minus plus 4x, let's say x squared minus 8, let's say 4x. So to group this, what you can do, you can take the first two terms, factorize them. The highest common factor here is 2, and so there's no other common factor there, so you have 2 outside the brackets, and then x minus 1 plus, now when you are here, you would want to have exactly what is in the first bracket. You want it to be in the next bracket, so you look for the highest common factor that will give you the same bracket as this one, using 4x squared and 4x. So the highest common factor here would be 4x brackets x minus 1. So it's this 4x squared divided by 4x, and the negative sign there, you keep it, and then 4x divided by the common factor, so that you get negative 1 there. Alright, we are not yet done. We continue with the next step. Now the next step is to just write what you have there in its simplest form. So you should have one bracket for the common factors, so to be 2 plus 4x 2 and then plus brackets x minus 1. So that is the final answer, and we call that grouping. So in other words, grouping is a type of factorization, and we know that factorization is the opposite of expansion. So those are a few things that you can look at, and then we move on to polynomials, equations, and inequalities. When it comes to polynomials, you look at things like long division, whereby, for example, they will say divide divide let's say 3x squared plus 6x minus 3. You want to divide it by a factor which is x minus 1. There are two ways you can solve this. You can use long division or synthetic division. So let's look at, for example, synthetic division. So synthetic division, you take the factor which is x minus 1. So you say x minus 1, you just say x minus 1 is equal to 0, and then you get the 0 of that factor, so you say x is equal to 1. And then from there you make something like a square like this, and then take the numbers in what you have to divide with. So you say 3, you write a 3 there, you write a 6 there, and then a negative 3 there. And then you take the 0 factor. So the 0 factor is 1, so you put a 1 there. And then from there, what you do, you first drop this number, the 3, you drop the 3, and then you multiply it with the factor so that you get a 3. What you get next, you put it under the second number, and then from there add the two numbers, you get a 9. Again multiply the 9 that you got, multiply it with the 0 factor, you get a 9, and in the end you add so that you get 6 as your remainder. So this is called a remainder. And what you got here is called a quotient. So the quotient in this case will be now you look at this, what you used initially there. So now when you have to write the quotient, the degree of this will have to decrease by 1. So meaning that initially you had x squared, now under the quotient the degree will be reduced by 1, so it will be just 3x plus the next one, now you have a 1, so the next one will just be 9. So this makes your quotient. Okay, the other one is long division, so that one you can look at it on your own, and sometimes you can also be asked to solve polynomials. You can be asked to write a given, for example, two fractions. You can be asked to write them as single fractions. So for example, let's say you have 2 over 3x minus 1 plus 1 over 4x. So you are asked to, you want single fraction, you want to write this as a single fraction. So what you do, you will look for a common denominator. So put that in brackets. When you want common this is just simple, you apply simple arithmetics, like let me say you have 1 over 3 plus 1 over 2. If you want to make these two as a single fraction, you always take the denominator of the other fraction multiply it with the numerator of the first fraction and also the denominator. And so we use these two to multiply it with the numerator and denominator. And then also you take the denominator of the first fraction and then you say 1 multiplied by 3, and also keep the denominator of the second fraction, multiply it with the denominator of the first fraction, and then in the end what you get is 2 over 6 plus 3 over 6. So now that the denominators are the same, you keep it and then add the numerators. So it's 2 plus 3, which will give you that. It's exactly this method that you should apply here. So in other words, now we'll have 2 multiplied with 4x over 3x minus 1 multiplied by 4x, and then plus, we use this denominator. Now we are going to use this denominator to multiply it with the numerator and denominator of the other fraction. So we say 1 multiplied by 3x minus 1 over, we found the 4x here, so what we are introducing is just the other denominator, that one. Okay, so now that the denominators are the same, what we're gonna do is just to add the numerators together. So just to simplify this, we have 8x plus 3x minus 1, everything over 4x 3x minus 1. So just to go further and simplify that, we get we'll get 11x there minus 1 over 11x over 4x brackets 3x minus 1. That is your final answer. You do not necessarily have to expand the bottom part. Alright. Next we have solving linear and quadratic equations, and solving linear inequalities. The best thing that you can do here is to look at, for example, okay, let's say look at quadratic equations. If you are asked to solve a quadratic equation, let's say you have a quadratic equation, let's say you are asked to solve the following quadratic equation, x squared minus 4x minus plus, let's say plus 6 equals to 0. Let's say you want to solve that. So what you do, you look for the factors, you write the factors of the coefficient of the first degree. What you have there, you have a 1 and a 1, and also write down the factors of the constant, which is 6. So you say it's 1, 2, 3 and 6 itself, and then you repeat this, but going backwards, 1, 2, 3 and 6. Now you look for factors in such a way that if you multiply and add them together, they will give you Okay, if you multiply, they'll give you 6, but if you add them together, will give you -4. So let's see. I think because it's an assumption, it might not be working out, but okay, let's make this a 5. So factors of 5, numbers, let's say factors of 5, it's 1 and 5, so it should be a -1, a -1, a -5, and a +1. So you say x squared minus 5x plus x plus 5, like that. Just to rewrite that, we have x squared plus x minus 5x plus 5. So in the end, you factorize this, you have x plus 1 there, you get x plus 1. Now the problem comes in here. We are supposed to have common brackets. The problem comes in the let's make that a positive, and this a positive, and this negative. Okay, remember it's an example, and we are doing it a try and error method. So let me say 3x squared minus x plus 6, okay, plus 3 equals to 0. You can use, let's use a formula instead of using this one. You say x, the formula x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So now you have to say x is equal to, we are busy solving for x like this. What is the b value? B value is let the b value be 9. 9, remember it's negative, there's already a negative that you found there, plus or minus square root of 9 squared minus 4, a is 3, c is 3, so you have that, and then everything over 2, a is 3. Okay. We continue. Now we have a positive 9 here, plus or minus square root of 9 is 81, minus 12 multiplied by 3. 12 multiplied by 3, you have 12, 12, that is 36. So minus 36, everything over 6. 81 minus, now we have 81 minus 36, we get 45. So x is equal to 9 plus or minus square root of 45. So use your calculator there to get the final answer. So we say the final answer should be x is equal to 9. Now you go for the positive one first, plus square root of 49, everything over 6, or x is equal to 9 minus square root of 49, everything over 6. So you use your calculator to simplify this, and if the answer is not exact, you have to write it in 3 significant figures always. Moving on, we have solving linear inequality and linear equations. Those ones you can look at them on your own. Logarithms and sequences. Learn about the laws of logarithms, like the quotient, power law, and product laws. So learn how to use them. Now moving on to graphs and functions. Drawing graphs is always the most problematic thing when it comes to students. So you should know the tips on what to do and what not to do when you are drawing graphs. For example, you always use a sharp pencil. You should not bold the lines. If you have to draw a straight line graph, that is the graph of the form y is equal to mx plus c, you should always use a ruler for a straight line. And for a curve, you should use free hands. Alright. And also, if you have to choose which scale to use, it's advisable if you can use even numbers for your scales, if the scale is not provided. Alright. Solving equations graphically. Let me say you are asked to solve for 2x plus y equals to 4, and x plus y equals to, let me say, equals to 0. So you want to solve those two equations graphically. In other words, these are equations that you can solve simultaneously, but then now this will be given on the graph and you'll be asked to, for example, you'll be asked to solve for x. So what you do, if they are given, this means that we have to look for the y-intercept and x-intercept of this. The y-intercept for y-intercept, you say you always should make x equals to make x equals to 0, because when the graph is cutting the y-axis, x is equal to 0. So now we say 2, 0 for this one, plus y is equal to 4. So in other words, this graph is cutting the y-axis at 4. Okay, while for x intercept, for the x-intercept, you should make y equals to 0, and then so you say, okay, I have 2x plus the place of 0, the place of y we put 0 equals to 4. So in other words, now we have 2x equals to 4, and then you solve for x. When you have to solve for x here, we have to divide both sides by 4. So you get x equals to 2. So, and let's solve for the x-intercept and y-intercept of this. Now we have y-intercept, the y-intercept there, automatically one can tell that if x is equal to 0, y is also equal to 0, so x is also equal to 0. So this is the x-intercept. So meaning that this equation is of a graph passing through 0. But then remember now to say, okay, when but then one can tell that, okay, y is equal to negative x. Okay, y is equal to negative x. That is the form of that graph if you just want to understand it better. So now to plot those two graphs, you can just say, okay, you have a rough sketch, whereby this line is a line of y is equal to negative x. So now also to consider this one, this is a graph passing through 4 and x equal to 2. So these graphs will meet somewhere passing through 4 and x equals to 2. Just a rough sketch here, passing through 4. It should be a straight line passing through 4 and 2. So where they meet, somewhere here where they meet, you read off that value and you say, and then you write x is equal to that value that will be there. It will be a negative value. So yeah. Moving on to functions and linear programming. So just look at functions and also linear programming. Now with functions, it's just the most troublesome there is how to write an inverse of a function. Let's say you want to find an inverse of 2x plus y is equal to 7. So what you need to do first, you have to write this equation in the form of y is equal to mx plus c. So it will be y is equal to negative 2x plus 7. Now most of the times when you talk about functions, we use symbols like f of x. So meaning that this equation would have been given to you as f of x is equal to negative 2x plus 7. So now to find the inverse of this, you just say you make this a y, and make that a y, so it will be y is equal to negative 2x. If it's given to you in this form, just make this an x, a y plus 7, and then now exchange y and x. So where there is y, you put x, where there is x, you put y, and then try to make y the subject of the formula. So this will be, you bring 7 to the other side, it will be x minus 7 is equal to negative 2y, and then you divide both sides by negative 2, so that you have y is equal to negative x minus 7 over 2. So your final answer should be written as f of inverse, this is the symbol for inverse, is equal to negative x minus 7 over 2. And then we have coordinate geometry. So you'll be given shapes like in a form of in such a way that they are perpendicular to each other or parallel lines. So just know that this equation here, m1 m2 is equal to negative 1, is very important. This is for perpendicular lines. For parallel lines, the gradients are equal to each other. This is for parallel lines. Just use that one. And then we have geometrical terms and the relationships, constructions, symmetry, and geometrical properties. So for geometrical terms, look at things like obtuse angles, reflex angles, what are they, and also constructions, that is locus. You have to look at how to do constructions using locus, and also symmetry, and know the properties of geometrical shapes. Mensuration, you need to know how to do calculations, most troublesome on combined figures, to find area, total surface, and volume. So for example, let me say you are given how you are asked to find the total surface area of this cylinder. You are asked to find the total surface of that cylinder. So I remember that this shape, this cylinder, is made up of three figures, of a circle, that circle there, and the circle that is at the bottom. And also, if you have to cut this open straight, it will become a rectangle. So total surface area would be the area of this rectangle. Now remember that here it's a circle, it was a circle that is cut open, so it would be 2 pi r, and then this one will form the height. That is now the distance from this point to that point, and this would form the height of the cylinder, and the area of this one would be pi radius squared, the same here, pi radius squared. That is the area of that. So the total surface area for this would be 2 pi r, which is the distance from here to here, 2 pi r multiplied with height plus now we have two circles that are the same, that are congruent, so you say 2 pi radius squared, so things like that. So you just substitute, if you know the h, you substitute it in there, the r, you substitute it in there. And we also have trigonometrical figures. We have trigonometry. You look at figures where you can be asked to find Pythagoras theorem. I mean, not to find Pythagoras theorem, where you can be asked to find an angle or a side. So if you are asked to find an angle or a side, you can use Pythagoras theorem, whereby you have to also use SOHCAHTOA, or if you are given non-90 degree triangles, you can use cosine and sine rules. So you learn how to do that. Statistics, I learn how to draw pie chart, how to use pie chart, how to interpret information from a pie chart, histogram, bar graph, how to draw them, and also know the difference between histogram and bar graph, and also how to draw a cumulative frequency curve and stuff like that. Probability, learn how to use probability scale, for example, and also just those simple calculations on probability. Transformations and vectors. The types of transformations, we have translation, enlargement, rotation, and refraction. So now when we look at the two types of transformation, you have to consider the types of transformations. You should know that if you had to look for a rotation, there will always be 3 marks for mentioning the type of transformation, that for example it's a rotation, and also the direction and angle, and the center of rotation. Those are the things you have to mention. And then we have enlargement. It's enlargement, which is the type of transformation, the scale factor that was used, and also the center of enlargement. And we have a reflection. You get 2 marks for reflection, and also for mentioning the mirror line. You also have translation, which is the type of transformation, and that's 1 mark, for example. And then you have, if you have to mention the other thing, it will be the vector that was used for that transformation. Okay, this makes the end of our presentation. All the best.